This is a lesson on integer subtraction from the Connected Math Series textbook, Accentuate the Negative, problem 2.2, and I will also combine some ideas from the Foundations curriculum in regards to what the chips look like. I started the students looking at a problem that they are familiar with, and as a chipboard model, anytime we have a positive amount, I'm going to use a positive sign, and a negative amount, I'll use a negative sign. We're also looking at the idea of a takeaway model here. So on the chips, I will be identifying which chips are going to be taken away or removed from the board. Both of these values are positive. So when I start my board, I'm going to start with positive 7 chips. 1, 2, 3, 4, 5, 6, 7. And then, because later it'll make more sense to, we're going to add in some neutral values. And my neutral field, and this is part of the CPM curriculum, that neutral field is made up of a positive-negative pair or a series of positive-negative pairs that have a value of 0. You might say they cancel each other out. You also might say they have no value. So even though we have these here, because they're neutral, we still are representing a value of positive 7. So from our collection of chips representing a positive 7, we're going to take away 5 positives. 2, 3, 4, 5. And just this arrow showing that they are being taken away is all that's needed. And then next we identify our neutrals. And then we look at what remains. And what remains is a positive 2. So positive 7 minus positive 5 is a positive 2. Now, switching that around is where we bring in the negative values. So my neutral field, I'm going to start with 5 positives, my positive chips, 5. Now I want to add my neutral field. I'm just going to add a series of positive-negative pairs, and I usually add 3 to 4, whatever I need, and sometimes I may have to add more. Sometimes I don't need that many, like in the first one. So from this collection of positive 5, I'm going to take away 7 positives. So here's my 5, 6, 7. Showing that those are taken away. Then I identify my neutrals. And then I look at what remains. So when I started with positive 5 and I took away 7 positives, I end up with a negative 2 remaining. So a similar example, starting with positive 6. 1, 2, 3, 4, 5, 6, and then I will add several neutrals. From this collection of positive 6, I'm going to take away positive 9. Identify any remaining neutrals, and then look at what's left over. So a negative 3 remains. So positive 2 minus positive 9 is a negative 3. Change that a little bit there. So a negative 5 minus a negative 3. So I'm going to start with my negative 5. And then I'll add in some neutrals. From this collection of negative 5, I'm going to take away 3 negatives. Identify my neutrals. And look at what remains. So a negative 5 minus a negative 3 leaves us negative 2. So this time I'm starting with what I took away last time. So I'm starting with 3 negatives, and I'll put in some neutrals. This time from my collection of -3, I'm going to take away 5 negatives. Identify my neutrals, and look at what remains. So a -3 minus a -5 leaves us with +2. Next kind of problem is when we're starting off with negative values and we take away positive values. So we're starting with a -5, add in some neutrals. From this collection of -5, I'm going to take away 2 positives. Identify my neutrals. And what remains are 7 negatives. So remember, these two are no longer with their neutral pair. So a -5 minus a +2 equals a -7. So this time I'm going to start with 3 positives, add in some neutral pairs. From this collection of a +3, I'm going to take away 4 negatives. Identify my neutral pairs, and I have no more neutral pairs remaining. So in my positive amount, or my other remaining pieces, I have 7 positive chips. That's 1, 2, 3, 4, 5, 6, 7. So a -3, or excuse me, a +3 minus a -4 equals a +7. The next model that I wanted to show was the number line model. On the number line model, we need to review back to problem 1.3, in which I had the students look at, and they were to write on their paper, the starting temperature plus the change equals the ending temperature. The starting temperature, let's say, starts at 3 degrees. There's a change of 4 degrees. If the temperature is rising, it's a +4 degrees. Call that positive. And the ending temperature following this change would be +7 degrees. Now, to turn this into a subtraction problem, I'm going to take that ending temperature and start with it. I'm going to take the starting temperature and take that away. And what I'm finding then is the change. So here's my ending, my starting, and my change. So on the number line models that they have in the text, this is kind of what they're doing. So if I start with a +5, here's the problem. +7 minus +5. And we saw in the last problem, we know that the answer is a +2. Here's why. This is my ending number minus my start number equals the change. So I'm going to end here at the 7, and I'm starting at the 5. The arrow always shows how far you're going and what direction. So it's going up 2 units in the positive direction. So it's a +2. If we reverse that and have this problem, we are ending with a +5, we are starting with a +7, and we're looking for the change. So we're ending at 5, we started back here at 7. This time the change is still 2 units, but it's in the negative direction, so the change is a -2. Now, this may not be the method that I would choose to use, but I wanted to interpret what they were using in the textbook as an example.